Hey, this is Mr. Janes. In this video, we're going to be talking about transformations. So first to start, what is a transformation? Well, a transformation is a change in the position, size, or shape of a figure. So as you can see over here, we've got this triangle, and we're going to be moving it around, changing the size and shape of the figure on the coordinate grid. But what about a map? Well, a map is, I guess, a character from Dora, the Explorer, but it's also the algebraic representation of a transformation. So what we're going to do is try and use this map to transform this triangle. So step one is to label the coordinates of that initial triangle. So go ahead and label the coordinates L, H, and Z. L looks like it's at -1, 0. H is at 0, -4. And it looks like Z is at -3, -2. Alright. Now what we're going to do is move those points around using this map. And here's how you do it. Start with one of the points. Let's start with Z right here. So Z. Z is starting at -3, -2. What we're going to do is move that to a new point. We're going to call it Z prime with this little apostrophe here. That means prime, or the new Z. And so we're going to use this map right up here. But instead of X and Y, we're going to put in the original coordinates of Z right here, -3 and 2. So the new place for Z, so Z prime, will be, let's see, 2 times -3, plus 1. The map comes right up here. And the new y coordinate will be 2 times -2 plus 4. Okay? And if we simplify that, we get, let's see, 2 times -3 is -6 plus 1. So the x coordinate will be -5. And the y coordinate, 2 times -2 plus 4, will give us 0. So Z started at -3, -2, but with this map, we now know that Z prime, the new Z, is going to be -5, 0. So let's see, that's going to be right here. So we'll call this Z prime, and it's at -5, 0. What I'd like you to do is take the other 2 points, L, which is at -1, 0, and H, which is at, let's see, 0, -4, and figure out where L prime and H prime are going to be using this map. Pause the video now. The answers are going to flash in front of the screen in 3, 2, 1. So there's some calculations for L prime and H prime, and just as a reminder, all I'm doing is taking this map. Instead of x and y, I'm putting the initial points, the initial values of x and y for L and for H. So like for L prime, I had 2 times -1, because I started with -1, plus 1, that's what the map tells me, and 2 times 0, because that was my original y value, plus 4, because that's what the map tells me for my y value. And if you go and simplify those expressions, you should get -1, 4 for L, and 1, -4 for H. So let's go ahead and plot those on the graph. Let's see, L prime, the new L is going to be at -1, 4, so -1, 4 will leave us here. So that's L prime at -1, 4. And H prime, the new H, is going to be at 1, -4, which is going to be right here. I guess that's H prime at 1, -4. And since my original figure was a triangle, I'm going to connect the dots between Z prime, L prime, and H prime to make that triangle. Alright, so you can see between Z prime, L prime, and H prime, I've got my new triangle. We call that new triangle our image. So the new triangle, again, is our image. And the old triangle, the one that we started with, is called our pre-image. Again, that's the pre-image, and again, pre because it's before we did this map, before we transformed this triangle into the new triangle. We start with Z, L, and H, and we ended with Z prime, L prime, and H prime. Now, the transformation we just did was a very complicated transformation. The triangle got bigger, it moved a little bit, and we're going to get to these kinds of transformations later on in class. But let's slow down for a second and break it down into 4 basic kinds of transformations that we can have. Here are the 4 basic kinds of transformations. We could have a reflection, also called a flip or a mirror, where the pre-image, this thing in blue right here, is reflected, I guess flipped, across a line. We call this line the axis the axis of symmetry because this image and the pre-image are symmetrical across that line. One important thing about reflections is that the distance from the pre-image to the line of symmetry will be the same as the distance from the image to the line of symmetry. So those are congruent. And again, that happens everywhere on the triangle. Those two are congruent, and I guess you could say from the far corner of those triangles, those are congruent too. Right? It's reflected directly across that axis of symmetry, so we get two symmetrical figures. A rotation, also called a turn or a spin, is when we take a pre-image, like this blue triangle here, and spin it some number of degrees around a point. This point we call the center of rotation. The center of rotation. And we spin it or rotate it a certain number of degrees. Could be 90 degrees, 180 degrees, 27 degrees, anything you want. Right? We're just spinning that around the center of rotation, almost like a pinwheel or one of those merry-go-rounds that you might see at an amusement park. We're just spinning right around that center of rotation. The next kind of transformation that we're going to work with is a translation, sometimes called a slide. And that's simply where we keep the pre-image the same orientation. We're not rotating or reflecting it. We're just maybe moving it left, right, up, or down, as if you're moving pieces on maybe a checkerboard or a chessboard. We sometimes call the direction that our image is moving in, we call that the vector. The vector, or kind of that direction or motion that our pre-image is moving to get to the image. The last kind of transformation we have is a dilation, which is also called resizing, enlargement, contraction, compression, enlargement, shrink, or expansion, a lot of different names. All of that it's saying is that we're taking our pre-image and making it either bigger or smaller. The point right here that we're making our image bigger or smaller from is called the center of dilation. Much like the center of rotation that we talked about before.